In today's video, we're going to be talking about how long it takes to purge chemicals from sand media tanks. This is often a question that we have out in the field is how long do we have to shut off the fertilizer injection before we can backflush the tanks. So today we're going to do a little experiment to figure out how long it takes for fertilizer to leave the system. We often recommend to growers that you inject upstream of the filters so that any precipitates that might happen or occur while you're injecting fertilizers don't make it to your irrigation system. The problem with that is that you might have that fertilizer in your backflush. So the solution to this is that you stop injecting your fertilizers prior to backflush. Then the next question is how long do you have to stop injecting prior to backflushing the system? That's what we're going to be testing today. So today we're working with three 36-inch diameter sand media tanks. These tanks each have about 7 square feet of surface area. So total it's around 20 square feet. For design purposes, you want around 20 gallons per minute per square foot. So that would be 20 times 20 would be 400 gallons is what these tanks would handle under normal conditions. So that's the flow rate we're going to have today for our testing. So the discharge to our media tanks is down here on the bottom, and we're going to be measuring the pH at this particular point downstream of the tanks to determine how long it takes for the acid to move through the tanks. All right, let's start by just seeing what the pH is of our water without injecting any acid. So I'm going to do that by cracking this valve open a little bit. We'll just get a small trickle coming out of here, and we're just going to measure some of the water from our reservoir. We've got our pH meter here, it's just a handheld one. We've checked it in solutions to verify that it's reading accurately. And so we'll go ahead and put this in here and mix it around a little bit. So it looks like the pH of our reservoir water is right around 7.1. The goal of today is to try to achieve a pH of around 5.5 and then monitor how long it takes for the pH to come back up to 7.1. All right, so today we're going to be injecting some acid. That's the pink stuff in the graduated cylinder that you see there. And we're going to be sucking it in through a venturi into our irrigation line, and this is all upstream of our filters. So again, we're going to try to get to a pH of around 5.5 and then monitor how long it takes for that pH to come back to 7.1. So we're injecting acid upstream of our filters today, and we're actually, we're not right in front of the filters, but we're upstream a little ways. So one thing you need to keep in mind is that the further upstream you are from the injection point or from the filters to the injection point, the longer it would take for the fertilizer to clear itself from the tanks. Often in the field, they'll be injecting right upstream of the tanks. So the results that we'll see today will be somewhat of an ideal condition where we're injecting just upstream of the filters. All right, we've got our acid being injected, and let's see what concentration we're at here, or what pH I should say we're at here. So that's saying 5.7 or so. We've been checking it here, and that seems to be right where we've been for the last few minutes. So I'm pretty confident that we have a steady pH here of about 5.7. There it is, 5.7 again. So we're still at 5.7. Now what we're going to do is we're going to turn off the acid injection, and we're going to collect water from this every 5 seconds and see how fast the acid dissipates from the tanks. And that'll tell us about how long it takes for the fertilizer to move through the tanks as well. All right, here we go. Go. All right, so we got our cups collected every 5 seconds. This is the first 2 minutes worth of data. We're just using this to show you how we're going to create the chart that you're going to see in just a moment. So what I want you to see is we're going to use our pH meter here. So I'm going to turn on our pH meter. And so this is time zero when we shut the chemical off. And so we can see what pH we have here. Looks to be about 5.8. Remember, we were at about 5.7 when we had a nice steady reading. Okay, then we're just going to keep going here, measuring each of these every 5 seconds to see what the pH is doing as time goes on after it got shut off. All right, so here's the last 2 cups that we collected, and you can see we're basically back to our 7.1 there. .0, 7.1, pretty much the same number there. Here are the results from our test to determine how long it takes for a chemical to move through the media tanks before a backflush should happen. You can see that we were injecting acid with a pH of about 5.8, and after approximately 2 minutes of time, the pH was back to around 7, which is where we started. So that means that we can shut off the chemical injection about 2 minutes before we backflush, and we should have no fertilizer in the backflush water. Keep in mind that this was for 3 36-inch diameter tanks, but it doesn't make much difference as long as the flow rate per square foot is roughly 20 gallons per minute per square foot. In other words, you should shut off the fertilizer injection or chemical injection about 2 minutes prior to a backflush. You might want to add a minute or two in order to be sure that you don't have any chemicals, but approximately 2 minutes is what it takes. Hopefully this video helps you answer the question on how long you should purge your media tanks of the chemical prior to backflush. Check out our other fertigation series videos. Thanks for watching.